All right. Today we're going to talk about section 3.5, which are transformation of functions. And we talked about the graphs of what are called the library functions previously. And transformations just involve shifting and or reflecting graphs about the grid. So we look at the library of functions, the graphs we will be shifting, and what basically we're going to do is we're going to be graphing these certain equations, I should say, without having to create a table of values. So just to refresh your memory, we've got the square graph. Anything with a x squared looks like a u. Square root graph, anything with a square root looks like that. Next we have the cubed, which looks like that. Cube root looks like that. And then lastly we have the absolute value graph, which is a V. So we are going to be moving pretty much this 0, 0 point of all of these functions. We're going to be shifting it either up, down, right, or left, or a combination of those based upon how the equation is given to us. So let's kind of look at first vertical shifts. And vertical shifts are up or down. And pretty much the way you determine if it is a vertical shift versus a horizontal shift is when something is being added or subtracted after the main library of functions. So in other words, if I am taking a number and adding it to something squared, cubed, absolute value, whatever, we simply shift the graph from where it started, which is 0, 0, and we would take this and go up 3. So we're going to shift the graph of x squared. We move it up 3. That's our 0, 0 point, and we just kind of make a rough sketch of it. So that is a vertical shift up. So the vertical shifts go with the sign. So that means I'm increasing my y values by 3 here. The other type of vertical shift would be when we're subtracting. Now again, we are subtracting 2 after we take the square root. So that means we would shift the square root of x down 2 units. That's where it starts. And we just sketch the square root graph. So keep in mind again, you've got vertical shifts. We are adding or subtracting after the main function itself. Now horizontal shifts are a little different. And sometimes this confuses people, and then all of a sudden we get horizontal and vertical backwards and all that stuff. So if you look at this equation here, this function here, we have x plus 4 squared. So in this function, I am adding the 4 before I square. Okay? So that tells me it's a horizontal shift. The other thing about the horizontal shift, as you can see, this f of x minus c means that the x minus the number or the x plus the number is all done before the main operation itself. And with horizontal shifts, we shift opposite the sign. So if I am subtracting inside the operation, I shift it right. If I'm adding, I shift it left. So if I look at x plus 4 squared, since I am adding 4 before I square it, I shift x squared left 4 units. So I would move that 0, 0 point left 4 and then just sketch the square graph. So a couple things you got to remember is you got to remember to shift it correctly and then also choose the right shape from the library of functions. Okay. So this function here, the absolute value, and again, I am subtracting inside the absolute value symbols. So this is a horizontal shift right 3 units. So I shift the 0, 0 point for the absolute value, and I draw the V. Doesn't have to be precise, doesn't have to be perfect. This is a kind of a shortcut way to graph functions without creating a table of values. So we're not worrying about when x is 4, when x is 2. We're just shifting the 0, 0 point and redrawing based upon whether this is a vertical or horizontal shift. Now we're going to combine horizontal and vertical. So, to separate the two, right here, this addition of 4 is vertical, this subtraction of 3 is horizontal. So to combine the horizontal shift, what I'm going to do is I'm going to shift f of x is the square root of x. I'm going to shift that main graph right 3 and up 4. Horizontal, opposite the sign, vertical with the sign. So I would take that 0, 0 point and go right 3, up 4, which moves it to there, and then I sketch it. Okay? And again, we will do lots of practice on these in class, but just kind of, you've got to know the difference between when it's a horizontal shift, when it's a vertical shift, and then making sure you choose the appropriate shape from the library of functions. So the last type of transformation we're going to do are reflections. So think about reflections. It's mirror images, okay? Reflections over the x-axis means it's a mirror image on either side of the x, because this is your x, even though that's kind of small there. And I think some of us still get confused between what's x and what's y. We reflect about the x-axis. Other reflections reflect about the y-axis. So there's a difference between the two. The way I like to describe it is when you have a negative sign outside, in front of the main function itself, then that's a reflection about the x-axis. Because what this does is, this makes us substitute in an x, we get an answer, and then we make it negative. So it changes our y values is what it does. It changes our y values. And so instead of, again, creating a table of values, we can just shift, or I should say reflect, because we are not doing any shifts. We should reflect the square root of x about the x-axis. So we take that 0, 0 point and we just reflect it about the x-axis. The difference between this reflection and this reflection is the minus sign here is inside of the square root. So when the minus sign is inside your main function or your main operation, that tells us it's a reflection about the y-axis. Reason for that is because before I take the square root, I have to change the sign. So think about, a square root of x. The number in here has to be positive. So the only way we can get positive under here is for our x's to be negative. So that's how this works. And so I just kind of sketch that. And that's your reflection about the y-axis. So just to sum this up, when you are reflecting over the x-axis, the minus sign is going to be in front of the main function itself. When you're reflecting about the y-axis, the minus sign is going to be inside of the main operation. So we'll pick up with this in class.